default block size is 64 MB. Can you see on the right hand side of the screen? And in Hadoop 2.0 it is 128 MB. Now while talking about a block size, if we keep decreasing the block size, what happens is there will be multiple jobs running parallelly. And if you keep increasing, there will be less parallel jobs running. So there is a trade-off, guys. It's like you have to see what will be the ideal, which determines what data you have, what kind of files that you are getting. Based on that, you are going to find whether 128 MB block size is fine, or do you need higher block size like 256 MB or something like that. To understand this, let's just take and understand or go in detail about the rack space in a data center or maybe in a cluster. So for example, if you see on the screen itself, there is something like a file called 200 MB size file, which is like one is on abc.txp and some other is like emp.dat file. Both of these files are we going to keep in one Hadoop 1.0 and 2.0, where 1.0 has a block size of 64 MB and 2.0 it's 128. And the reason why we are going for optimal blocks is that if you reduce the block size, the overall theory is it looks like that the jobs will run faster, but actually it processes the data and it becomes very difficult for you to move and get the data, and it is going to increase the seeking time of your terms of data here. Everyone, are you able to follow me what I'm saying? Guys, when we increase the block size, as like in Hadoop 1.0, hello guys, are you there? Hemant, Mukul, Sandeep?
Yeah, we're getting you.
Yes.
Yes, yes, we are following.
Okay. So when we increase, when we increase the block size, you know, the seek time or the process of moving or getting the data is going to increase the seek time in terms of data. So that's the reason in Hadoop 2.0 it is recommended that the default size should be 128 MB. So the larger the block size is going to add two terms here. First one, easier to locate, and second one is as you go on having a larger block size in terms of a main memory or in terms of a name node, it is going to create a less overhead, because data is going to be stored in few blocks and metadata management itself will be very light in content. So that's the reason Hadoop 2.0 has become very famous in terms of data handling and distribution and processing. Now talking about in detail about the blocks here, so in 1.0 we have 64 MB blocks, 364 MB blocks, and the last one is 8 MB block now. Theoretically, if I reduce this to 32, see that there are like currently there are like 4 blocks running. If I reduce it further to 32 to increase the blocks here, and then the assumption that the work ethic will be or the execution process will be very faster. No guys, it's other way around. If I reduce it to 32, these 4 blocks will become 8 parallel jobs which will be running. But then overall there will be something called as managing the contacts and switching. There is a process called switching, guys. It's going to take much more time, and the benefit that you get is very less by having multiple parallel jobs. So that's the reason what these guys or the architectural layer we design patterns in Hadoop 2.0 is always statically mentioned, not dynamically. It's statically mentioned, saying that as we have a larger file size, please go opt 128 MB or 256 MB, so that the block size will be very less and the processing will be very faster. That's the first thing that always they take care of, ensuring that the block or the data content or the file, when they are switching from one to another, should never be more in number. because 1.0 the replacement is done with 2.0 regarding the default block size. Now, okay, we agree that we reduce the block size and so that the processing makes much more faster. Now, how is the data is going to be placed across the blocks? How the name node is going to identify the machine where the data is going to be placed with. See, yesterday we talked about the data is going to distribute between data node and name node. Remember all of you? Right? So we will discuss about how this name node will keep the metadata content and everything. Going to the next slide. I just gave you a pictorial representation here. It says, yes, this is called as replication or rack awareness. Okay. So I have almost like 3 different blocks here, guys. And I have almost like 12 different machines, 4 in each rack. Okay. The reason why we go for this rack awareness process is, first thing, as I said, how the data is going to be placed across the blocks, how the name node is going to identify the machine and where the data is to be going and where it should be placed. Third important thing is, we need to know how the name node is going to identify the machine where data need to be placed. In the slide, as I said, in the slide we have the multiple machines, around 12 machines that we have. See, for normally people will prefer something called as a data center, guys. Hopefully everyone knows about data center. Guys, Dhruv, Hemant, Mukul, Sandeep.
Yes.
Yeah. What they do is yeah, buddy. So what they do is they go ahead and keep all these different machines where we distribute in the data centers across. So what we have here is, we have a file that has 3 blocks like A, B, and C. We are going to distribute the data across these machines that we have here, from machine 1 to 12. Generally in data centers, we don't keep all the data sets together. What we do is, we connect all these machines through a switch here. So something like, hang on, let me give you 1 second. This becomes, can you see this? This is my, 1 second, let's just give me a minute, please. Okay. Can you all see my screen? Everyone? Guys? You're able to see the same slide, right? Everybody?
Yes.
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 Okay. Okay. Now, we're talking about the racking system here. So I was saying about a switch in the data centers. Using that switch, we go ahead and connect all the racks here. The reason why the data will be erased in the racks is, like in the sense, erased in the sense, it will not be stabilized. It will not be available forever over there.
Audio cut. Can't hear you.
Hello, Mahesh. Yeah, I think his audio is down.
Hello? Hello, guys, can you all hear me?
Yeah, we can hear you now.
Yeah, I'm sorry, guys. There was a power surge, so I got disconnected. Okay, hang on. I'm sharing my screen again. Okay. Hello, Mike, are you there? Mike, can you please make me as presenter? Mike, can you hear me? Okay, guys, can you all see my screen, everyone?
Yep.
Yes.
Okay. Yes, guys. So we are talking about the storage in the data center. So in terms of reliability, in terms of the data center rack awareness process, which is used by the name node. Everyone remembers name node, right, guys? Name node and data nodes. What are those, guys?
Name node is the master.
Okay, what does it do?
It stores the.
It
has
stores
lots
the
of
metadata. The
Sorry,
name
what does
node
it
gives
store,
back
guys?
the jobs to the data nodes itself.
Yes, it gets the jobs to the node, exactly. So what happens once the job is sent to the data node there?
Given to the job trackers. Individual job trackers.
So the main responsibility of a name node here is to?
To delegate.
Yeah.
Yes. So whenever there is a rack awareness process implemented, name node is the first thing that comes into the picture in data centers. Because as I said, you have to bring something called as reliability in the system. And so that we have it in data centers, mostly the concept of rack awareness, which is taken into consideration, in which we can go ahead and keep the data across racks, and whenever you store the data will be available in a different rack format. But for that, you need to store your racks in one machine or another machine. So on the slide, if you can see, on rack 1, machine 1, I started including my block A content. So in this block A content, out of 12 machines, I'm going to put block A in rack 1. So this concept of rack awareness is used. It will be started by name node only. So what you will do here is you will provide a network topology, like how you have divided these machines across the blocks. Basing on this, how is it going to pick a particular block and going to distribute that? So here we have picked one machine, and we placed very first copy inside a block. Very first copy of a block inside one machine. Now the data is going to be replaced in other two machines as well, the same copy. It will be the same copy again of block 1 or block A. What I'll do is I'll start replicating my data again into the next rack like this. So the same content will be available in rack 2, machine 5 or 6. So the usage is, if you lose rack 1, you still can have the data accessed from rack 2, and vice versa, guys. If you lose rack 2, you will be able to still access rack 1 content. Similarly, talking about block B. Now assume that the first copy of block B is going to pick randomly, guys. Now once it is identified, then the other two copies are going to be available. So it has picked one random content in my rack 2, and I saved it inside machine 6. Talking about the other two copies inside these racks, we are going to place everything based on a rack awareness logic, which a name node starts working on. So now it's the first copy in the block. We have it on a machine 6. So the other two copies will also be replaced, or will be applied or going to be settled with on machine 10 or 11 like this. So we have started using all the racks in different machines, but the same kind of data is replicated. Now for the block, it is going to be something like the third block C. It is going to be something like machine 12. So the other two copies is going to be on machine 2 or 3 like this. So distribution goes in this pattern. Now, how is that the data is going to be distributed across the racks? So even when one machine goes down, you can still access the data. So the name node here uses something called as a rack awareness concept. And guys, basically to make you understand, we distribute the data. So whenever we need the data, it is accessible or available completely by us through the Hadoop clustering process. No problem, Sandeep, that's okay. So as we came to know the data storage technique here, let's try to find out how do you write operation and how is it going to be performed. So in terms of reading and writing, what will happen whenever you want to access your data and all. Okay. So in data set, yes, buddy, yes.
So just so I get this right, I'm trying to follow the pattern. I think I got the pattern of how it allocates the data. So for example, the green data itself, the block C, you put it in 12, 2, and 3. Now let's say if it was 4 packets of this, it would be 12, 2, 3, and 4, correct?
Yes. Yes, okay, Mohammed.
So it adds on to 1 each time it goes to a different block. Okay, that makes sense.
Yes. Right. Adds on, it goes to different blocks, different racks. Everybody got what I'm saying? Oh, come on, yaar.
Yes.
Guys, I believe. Okay, my machine is restarting. Why? Can you all see my screen? Everyone, guys?
Yeah.
Can I see the same PPT here? Okay, there it is. You are seeing the same slide? I'm sorry, yeah. There is a problem going on here. Yeah, okay. Okay, now, guys, in terms of allocation here, to clarify your answer more, Mohammed, in terms of allocation, the data content, after it is shared, we are supposed to identify. As I said, we use something called as a switch, and each switch will monitor and manage the consistency and the sharing process. So that, normally, usually we do have switches, guys, which will immediately switch on when there is a backup failure is happening. So that's how the data centers is. We will not maintain machines here. We will allocate machines in the data centers and see that there are independent machines running on for our clustering process. And inside those data centers, we start accessing the content in a different format. While doing that, switch plays a main role from one rack to another rack. Okay, so you will be given access to those racks, and you will be completely ensured that the data content that you are supposed to work on with is available in those racks for sure. Not only on one rack, guys, every rack on different machines like this. So the distribution process will be completely done across all the machines. I took only 12 machines here, guys, as a sample. So each and every machine, it's not mandatory that all the machines should have all the content here. As a replication process, you will have it either in one rack or another rack. But for sure, there will be a switch so that you can access 2 racks at a time. Whatever is available, it starts going and accessing the track and then provides the data for you. Even if one rack is busy accessing or sending data to another request, another rack will switch, immediately come back to you and then start working on it. So that's how it goes on, guys. Okay.
So the distribution is in such a way that even if one complete rack fails, we have access to the entire data.
Yes.
In the other 2.
Yes, buddy.
Okay.
Even then, if you keenly observe, if rack 1 and rack 3 are off,
yeah,
which data will be affected highly? Data will be affected. There is a problem here, guys. I don't have block C data in rack 2.
Yeah.
That means if 2 racks, that means the allocation, main thing is allocation here, guys. You need to know how many machines or how many, in a cluster, how many machines are available and how many number of times I can make my data available, not just like accessible, guys. I need it available. So that once I start accessing my content, I should ensure, as a Hadoop developer, I should ensure that all the racks are aware of the data content which I'm trying to access. Else, if something goes wrong, I cannot exactly. Are you there? Hello?
Yeah.
Yeah. I apologize, guys. There is a huge power surge going on. It's coming on and off, and it seems like I need to switch back to a alternate source. Can you all just give me a minute, please?
Sure.
I'll be right back in a minute, guys. Please. Mike, can you hear me? Can you please make me as presenter, Mike? Mike? Guys, can you all see my screen? Everyone?
Yes.
Yes.
Okay. I'm sorry, guys. I'm sorry for this inconvenience. I don't know, student is going off and on. Okay. Yeah, we're talking about switching process, guys. So,
Mahesh,
yes, buddy. Yes, buddy.
yeah, I'm sorry, but can you please explain the function of switch? I didn't understand it fully.
Yes, buddy. I'm coming back there. Now, see, switch is something which will help you to, as the name suggests, which will help you to switch from one rack to another in case of absence of an existing rack or the access or the rack that we are trying to access. Now, here on the screen, if you keenly observe, guys, on rack 1, you can access block A and C content. On rack 2, you can access block A and block B content. On rack 3, you can access block B and block C. So the biggest hassle here is with block C only. Okay, because block A and B contents are completely available on rack 1, 2, and 3. Even if rack 3 goes down, you have it in rack 1 and rack 2. So even if rack 1 goes down, you will have it in rack 2 and rack 3. So A, B are safe because they are distributed across. But when it comes to C block, the data content here is distributed in only rack 1 and rack 3. So if both the racks, like if the rack 1 and rack 3 are gone, you will never be able to access the block C content at all. So even if a switch that is trying to switch from one machine to another machine, try to find the data content available in a specific rack, you will not be able to access the data content at all. You will not be able to access the block C content at all. So how will you start using it, guys? Any ideas here, everybody? Shall we keep block C content also in rack 2? How do we decide on that? If you understood the concept, you will be answering me now. Everyone. Hemant, Mukul, Sandeep, Mohammed, Dhruv.
Increase the replication factor.
Okay. Okay. And what else?
Could you just repeat that one more time?
Yeah, sure, Mohammed. See, I was asking about accessing my or processing my data content available in various racks. In rack 1, I have block A and block C content. In rack 2, I have block A and block B content. In rack 3, I have block B and block C content. While trying to access, for example, assume that there is a failure in rack 1. Immediately, my switches in the data center will allow me to go to rack 2 or rack 3 and give the nearest content fastly available for me. So I'll be able to get the data without any hassle. And if rack 3 goes down, I can still access rack 1 and rack 2 and all the sets of data. Absolutely fine. So block A and block B are completely accessible. Now talking about block C, I have a failure in rack 1 and rack 3 for example. Now here I don't have block C content in a rack 2, wherein my switch, even it starts working on, won't be able to find the exact data. So what would be the best possible way to identify the non-availability of data content in a rack? It's a simple logic, guys. We came across the distribution pattern. Yes, guys.
Make sure that
Sorry. Yeah. What is it, buddy? Make sure what?
Make sure that each copy is on different rack.
Okay. How is that possible?
So, for example, here block C, there are 2 copies of block C on rack 1. But if we ensure that every copy is on different rack, we can access block C from rack 2.
Okay. See, here it's like we have divided all the data sets in all these machines across blocks. Based on this, we are going to pick a particular block and going to distribute that. So this picking of this first block or second block or third block or first rack or third rack, it completely depends upon something called as replication. Now assume that in the first copy of the block B is going to pick randomly. Guys, once it is identified, then the other 2 copies are going to be placed based on the rack awareness logic, a topology which you send across on the machines. So while sending the data content into the rack, you need to first decide which rack you want a content available in, for which you need to know the entire concept of data centers. I mean, it's not mandatory that you should be an expert in that, but which machine is allocated for our storage purpose, and what are all the machines available? Are they on the same location or in a different data centers or the same data center? If you are keenly understood, or if you have a grip about those details, you will be able to decide where exactly to store the data content so that you can replicate the same in another racks also or in another machines also. So here the biggest disadvantage on this distribution pattern is block C. Assume that. Yeah. Hello. Yes, guys. Somebody has a question. Okay. So here assume that we have block C content only to be accessible. So if something goes wrong, yesterday as I told you, if every machine goes down which we are trying to access, that's the biggest hassle in our daily work ethic. We have to raise tickets and then see that it is completely resolved, so that the machines are accessible completely within a short time. And for every there will be a turnaround time, guys. If one machine goes down, they are supposed to look after the enabling the machine back again onto the rack and start making it accessible. So that's how it is. So you decide on where exactly the data content goes on, and then randomly your content or the rack awareness process will decide and make your data available in another racks also. Okay, am I clear regarding the allocation and the storage process and decision factors and how the data will be stored in different racks? Everyone?
Yeah.
Yeah, but did you give the answer to the question you asked? Like, what is the answer? How do we ensure it?
Yeah, we ensure it using a rack awareness process, buddy. A topology wherein we decide among the rack, we pick randomly and use the identifiers or the two copies that is going to be placed on a rack. So something like, similarly the allocation which we do might be on rack 1, 2 or 3. While doing that, you decide which rack that main data content or the first copy of this data content should be available on. And then the other two blocks or other two racks are automatically or randomly decided by the process called rack awareness itself. Okay? So
Yeah, so
my suggestion, yes, buddy. Yes, Hemant.
no, go on.
No, so my suggestion would that be, I decide whether to go for rack 2 or rack 3 and ensure that my copy of this is available on rack 1 also. So if all the racks goes, as I said, that will be a biggest hassle. You won't be able to attach base any machine here in those racks, because you have to raise tickets and then resolve it as soon as possible. If only one rack goes down, you can switch back to other racks easily, as we use switches here inside the rack awareness, done mostly by the name nodes. Okay.
So in this case, block C would ideally be divided into all 3 racks.
As usually, because if you see, rack 2 and rack 3 are available, and rack 1 and rack 2 are in common.
Right.
If my rack 1 goes down, 2 and 3 are completely available with the same data. If my
Right.
rack 2 goes down, rack 1 and rack 3 are completely available with block A and block B data.
Yeah.
If rack 3 goes down, I still have rack 1 and rack 2 for accessing block A and B. But for block C, if any two machines goes down, something like rack 1 and rack 3 went off. In my rack 2, I don't have data content related to block C at all. That's a hassle, right? So that's why I just gave you this information like this. So you need to decide, guys. Being a Hadoop administrator, you need to decide, for which you need to understand the data center completely, the allocation process, the switching allocated within them, the rack awareness, which rack is allocated for our data to be stored on. You will be deciding on that. And how do you make the decision factor? You need to intervene into those machines and find out which machine is feasible for your data content which you are going to store, and how you are going to access it back, and how you are going to make it available for accessing. That is the main content. Got it?
Well,
Everyone, are we clear so far?
right?
Yeah, this is practical. That's what, guys. Probably by Tuesday, I might be replicating this for you. As I promised, I'll be walking you through. That's what I'm giving you, the actual live implementation for the data accessing, the processing, storage, reading, and writing also. Okay. Am I clear so far, everyone, regarding rack awareness, replication of rack awareness? Everybody?
Mahesh, I have a question.
Yes, buddy.
So if our replication factor is 3, we will be creating 2 copies of every block, right?
Oh, in the default.
So we have to make sure that as an administrator, those 2 copies will be residing in 2 different racks and not on the same rack, right?
Yes, buddy. Yes. See,
Okay.
it's not mandatory. It's not mandatory. But what I'm saying is the best solution for that is, see,
Yes.
my replication for if you keenly observe, my replication for block A is in rack 2 only,
Right.
right? But in rack 3, there is no replication at all for block A.
Right.
But even if rack 2 and rack 3 are down, my rack 1 is ready with my replication data content. Now, guys, here there is also one more issue with block A. If rack 1 and rack 2 is gone, can we be able to access block A content?
No.
So that's
Similarly
the
with
problem.
block B also, like if rack
Similarly,
2 and rack
yes.
3 go.
Yes, buddy. Yes. I'm talking about every block here. I took an example of block C only, guys.
So ideally, every block should be distributed in all 3 racks, right? Like say.
That's what. Yes, buddy.
Okay.
Yes. The replication should be happening in every machine. And if you observe, there are empty machines running on racks. Rack 1 has 4th machine available. Rack 2 has 7 and 8 machines available. Rack 3 has machine 9 available.
Right.
That's what I'm saying. You need to understand the allocated data center. Which machine is still available for accessing? Please make your replication available over there also.
So is this an example of how it should not be done?
It should be done. It should be done. How it should be done in sync? How it should be extended?
Okay. All right.
Okay. Because we have empty machines also over there, Hemant.
Right.
Right. We didn't allocate any machine for, any data content for those machines. So I left those machines intentionally to make you understand if this possible ways, like if some 2 racks at a time went off, then the other machine should be ready for me. That means on fourth, for example, on rack 1, fourth machine, I should have block B content also.
Yeah.
Mostly guys, it is something like making it available and accessible. How is that it is available? Just ensure that all the blocks are available in all the racks here. My bottom line is. Now, as I said, if all the racks went, all the racks are down, we can't do anything, guys. That's the highest level 1 issues are all coming up, and then we have to go for resolving those issues and all. That's the other side of the coin. So it's very rare that all the racks will go down, but see that in every rack you have all the block content available.
Mahesh,
Find the data center. Yes, buddy. Yeah, Mukul.
So from where does switch come to know that okay, this rack is down, I have copies on this rack, so I should switch on this rack? How does
inside data centers, when specific racks are allocated for your distribution process, they will automatically allocate switches for one machine or one rack independently. By default, that's the nature of a data center, Mukul.
So there is in cluster there is switch per rack.
Yeah, per rack, exactly.
Okay.
It's not per machine, buddy. It's per rack. Okay.
Okay, per rack. And is there any communication between name node and switch?
Yes.
No.
Yes, buddy. Yes. Because rack. If the rack is available, then only name node can start rack awareness logic. How does a name node know whether the rack is available or not? Through the switches only.
Okay, great. Okay.
Got it? Guys, yeah. This is just a small implementation I'm trying to say, guys. This is like only 3 here. There will be like hundreds of racks available for us, guys. Okay? So it's like, in a Hadoop implementation or administration process, you will be given modules of data to be allocated and accessed and make it available. So each person in the team. So you will take rack 2 and rack 3 and rack 4, for example, and Mukul will take rack 1, rack 2 and rack 3. Mohammed will be taking rack 2 only. Hemant will go look after rack 3, 2 and 1 completely. So all of these persons' interest is looking after the availability of the data content and is it accessible by users of the data content. That's it. This is called rack awareness, guys. Okay. Got it, everyone?
Yep. Yes.
Any questions, guys? Everybody?
No.
Okay, let me go to the next slide then. Now, guys, this is a process for ensuring how do we read and write data content into my racks. Okay. Now, see, in this example, apart from the name node, we also have something called as data nodes. Here comes the major role of switches, guys. Can you all see there is a switch on the top and also in the rack 1 and rack 5 also, guys? Everybody?
Yes.
Can you see this slide, everyone?
Yes.
See, I have a pipeline going on from client, from this person, one client, and he is trying to access rack 1 and the data node content inside the rack 1. While trying to access, my switch is interrelated with rack 1 and rack 5 also. I just took rack 5 here. So inside this, I have data node 5 and data node 6 also. Now the bulk data content which I have in the file format is A, B, and C. Can you see these blocks here?
Yes.
What happens is when a client tries to access the data node 1 that is available inside a switch, my rack will make a replication of data node in other rack also. That is a default behavior. So we make it distributed. We allow it to distribute, and internally each rack will talk within a process called switch. And if you observe, there is a switch for each rack, and on top of everyone there is a controller switch also. Okay, so the controller switch will allocate or will try to look after if something goes wrong. It will try to switch from one rack to another rack. and it intercommunicates between one rack to another rack for accessing the data. And for your information, guys, if you see, the entire block A content only is available in all the racks. Can you see that? Data node 1 is with block A, data node 5 is with block A, data node 6 is with block A. Everyone. This is called rack awareness done by name node. Inside name node, we'll have data nodes. So the name node will take care of rack 1 and rack 5 at a time. Besides its work on data node 1, data node 2 and 3 with a block content called A. Everybody. You got what I'm saying or no?
The data node became replicated, is what you're saying? Data node 1 replicated into 5 and 6?
Data nodes are separate, buddy. Data node is separate in the rack. But inside the data node, my data content or the block is replicated.
That's replicated as soon as they put it in, right? That's what,
Exactly. When I put my first copy in rack 1, it's replicated. It's replicated here, but the data nodes are different in another rack.
Mm-hmm.
Because that we can control, guys. Yeah. Yes, Mohammed.
Okay.
And this is called rack awareness, guys. Everyone. And on top, name node is the person who takes control. Now, a question comes: what about block C and block B?
Well, block B would probably be for data node 5, and then be replicated. If these are the only 2 racks, which I don't think they would be the only racks, because you have rack 1.
I just took a small example, Mohammed.
Yeah, but assuming that it would be something like this, it would be data node 5 would have B, and then 6 would have B, and then the third one would be made for data node 1.
Yes.
So the primary would be for 5, and for block C, the primary would be 6.
Yes, boss. Excellent. That's how it goes on. Everyone?
Yep.
Got what said? Everybody? Hemant?
No.
Mukul? No. What we're trying to say here is we have racks here, Mukul. See, assuming that we have only 2 racks, guys. Okay. In my rack 5, I have only replication for my A content or a block A content. So we make it available, or the first copy of my block B or C available on rack 5 data node 5. Okay. So that will be replicated in rack 1 also. That's the default behavior, right?
Right.
Switch is the one which takes care of entire thing. Okay. So what happens is you will pass data along it and receive it the data content. So the data is distributed across and made available or accessible by the entire data center or the entire cluster or the entire machine or the entire rack available. Don't assume that there will be only 2 racks, guys. As I said, I took it as an example. There will be several racks available. So if not one rack, the other rack will be ready. But as I said, please make or ensure that you have a complete rack process understanding. If you don't understand the rack process, you won't be able to work on it. The reason is if some racks goes down, you have to make it available or accessible from another rack also. If you don't know which rack is having which content, that's no point in working at all with the name node.
So this data is available in the name row, right? Which
data node, buddy, data node. It is available in the data node, which is maintained by rack awareness logic by name node.
I mean the data of which rack and which data node contains which block. This information.
I have block A, Hemant. Okay.
Yeah.
I just took only block A. I didn't took block B and C. Leave C and D part. We are talking about block A here.
Yeah. Okay. So the question is the information on block A on which data node block A is stored. This information is stored in the name node. Yes.
Yes.
Okay.
On the right hand side, if you see, that's what is rack awareness is.
Right.
Name node will have a complete information about rack 1 and rack 5. I mean, any racks which I have inside my cluster. And it will clearly have the tracking of the data nodes available in those racks. And once we have the tracking, for sure you will have an access for your blocks.
Got it. So the data node.
Yes.
The
yes, sir.
data nodes individually, they don't have any metadata, right? They just have the blocks stored on them.
Block stored. That's it. That's it.
So they don't
As
have
it is
any
a
information. Yeah.
as it is a replication, it will be replicated. See, if you see
Yeah,
a
I understood that.
client on the top, yeah. Yes, buddy. Sorry. Go ahead. Go ahead. Yes, Hemant.
No, I understood this. I understood the rest. Yeah.
Now here, guys, it's like when the client start accessing the original copy or the first copy of my data content, he starts writing into data node 1, which is in rack 1. Immediately, that will be replicated into data node 5 and data node 6, guys. Okay, everybody.
Yes.
With
Yes,
a person called switch, and it is replicated and distributed. So client always access the first copy, and we will be giving access to that first copy only. We will never be giving access to the second copy or the third copy or the replicated data content in another racks. So any changes made to a file inside the main first copy in rack 1 or rack 5, wherever it is completely done by the client, and this process is called pipeline writing. So it will go in a sequential order. Am I clear so far, everyone?
yes.
Yeah.
Okay. Cool. Now we are going to distribute this data content, and once this data content is ready, we can start writing and reading, and wherever you want, we can take this content, migrate, distribute, access, and make it available. Everything you can play around with this. Now, talking about a map reduced content, we are going to start map reduce probably by Tuesday. On Monday, we have a biggest concept to be discussed with. But before we go ahead, are we all clear till now? Any questions like yesterday session or day before? Are we all clear regarding the architectural layer? Are we all clear regarding the concepts here which we discussed on name node, data node? Everybody?
Yes.
If you want me to repeat anything, I'll repeat it back. Just let me know. Because Monday. Oh yeah.
No, it's clear for me.
Yeah. I'm still getting confused between function of, how name node and switch function together. Because we have switch for rack and there is another switch for switching between racks.
Nobody. See, switches are something. Mukul, assume that switch is something like an internal component of each and every rack. Okay. Now, when I'm supposed to connect one rack to another rack, I have something called as two protocols here. Okay. A protocol which help me to understand the rack awareness logic. So to know that there will be a master switch available, and through that master switch, I'll interrelate or interconnect between one rack to another rack. Okay. So talking about a name node here, name node will try to access the content inside the rack, which already have a switch. So while trying to access, switch is not talking to name node here, Mukul. Name node is talking to data nodes here. While accessing the data node, switch will monitor whether name node is perfectly trying to access the data inside the rack. And immediately while trying to access, if the rack 5 went down, switch will inform the master switch, the parent or the child switch here. The child switch will directly inform the master switch saying the rack 5 is down. Immediately it will switch back to rack 1 for the purpose of name node to access the data content. And if the block is available in the rack 1, which is already up and running, name node will be able to still access it in the same way.
Okay. Yeah.
The role of switch is to identify or monitor the name node process in a normal layman terms, buddy. Okay.
Thank you.
Okay. Yeah. Everyone, guys, are we clear so far? Everybody. This is how the major blocking is, and this is how the distribution process is in my data centers that happen in a real-time scenario. Everybody?
Got it.
Yeah, okay, cool. So on Monday onwards, what we're going to do here is, we are going to replicate the data content. I'm going to show you, we have something called as NoSQL in Hadoop base, which is like a database for us. Then you can create your data and you can manipulate your data content back and forth. The biggest advantage here is you try to access the data content in a sequential order. Now, who decides that? That is the biggest concept in Hadoop base. While I'm trying to access my data content, Should I have to touch base rack 1 first or rack 5 first? Who is deciding that? No, I said that the first copy is the one wherein the accessibility is given to the client. After the replication is done, who decides which is first copy and which is not first copy? Everybody, are you following what I'm saying?
Yes.
Rack awareness algorithm of name node.
No, see, once you start accessing the rack, then comes the rack awareness logic, buddy. But
Would there
before
be
that,
a specific key value pair assigned to each one of the files?
yeah, if I have a key value pair, Muhammad, for example, if there are only 2 racks here, so the key value pair will easily allow me to identify the content. If there are like 100 racks, how many key value pairs will you be running behind? Makes sense,
Well,
right?
aren't the key value pairs like just specific to that file itself?
Not just the file.
Okay.
It's specific to the replicated content. Guys, that's what I'm saying. See, last time in the last slide, what did I told you here in this slide? You need to first understand your data center. Which machine is allocated with which data? Which machine is not allocated with the data? Identify that first. That means you are trying to identify where the data is replicated, where the data is not replicated, and which machine is still yet to be allocated. And you are supposed to understand this at any level, guys. At any cost, you need to have a complete fear in the field. So going ahead, when I start writing my content in such kind of environment, or maybe inside the rack or the data inside the rack, I need to make sure that this is completely available and accessible, even if there is a cluster failure. The rack failure is. Now here comes a question saying, buddy, you said no, you'll go and copy the data in one of the machines which is readily available. Okay, done. That we consider as first copy. How do you be given an access for that rack? How will you go and start writing your content? Who is gonna validate the content inside the rack which you have already written or the user has already written? Once done, and I'm supposed to access, it means that I have to make this data content available to some compiler. Guys, I wrote some code in my file, guys, in my block here. That code is to be available with for a compiler, so that that compiler compiles the code and start running it and blah blah and all. That's for programming. We are not talking about it right now. Making this data content available to that specific logic or specific specific blocked content in a specific rack for a specific user. What is the biggest thing that we are supposed to look after? And how is that I'm going to access? Do I first have to access the replicated data, or do I have to first access the first data which I have copied? Who controls this? Again comes the concept of name node here, guys. This person don't understand name node, guys. This is like a huge bunch all across, even in MapReduce also. This person will control something called as YARN process and also HDFS cluster, Hadoop file system cluster. So in 2.0, we do have YARN. If you remember the architectural design of our slide, we have a rack. We have a HDFS cluster, right? Remember the architecture, HDFS architecture for Hadoop 1.0 and 2.0.
Yeah.
It's been replaced with YARN. The HDFS file system is replaced with YARN here, and then it starts working on. So you need to know how to connect your components of HDFS, YARN into your data center, access the data, supply it back again to HDFS or YARN, whatever is the component is, and those guys will be able to track your content. They decide which rack is to be first touch based with and which rack is not to touch base with, even if there is a replication data available. And how is that and everything? We have a step-by-step process, guys. And I will yesterday I told you I'll be giving you a document. This is the document I was talking about. I have a step-by-step process to perform the clustering and taking control of the data accessibility and availability. So I'm going to do that for you. Okay. So I'll send it to everyone. Please go through the document so that it will be easy for you to for you to understand what we are doing on Monday. Got it, everyone?
All right.
Any questions, guys? And please don't miss this Monday's class, everyone. So that's huge, huge in terms of understanding the MapReduce process and in understanding the YARN, the file system, everything, guys, everything. Okay. Are you clear regarding every concept till now?
Yeah.
Yes.
Okay. And Mukul, and who is that other person? Is Sandeep, right? Guys, we are planning to give you a small recap session. We'll let you know once it is scheduled, guys. Okay.
Okay. Yeah.
Yeah, because you missed the first two sessions, right? So yeah, we'll come back and then we'll walk it through. Others, if you want to, you can join also. That's not a problem. You will be informed about the recap session. So that's what it is from me and this weekend. Tuesday we are going to set up these machines, give access for you. Monday we are going to walk through how to take control on the replication process. Once done, then we go for map reduce or advanced map reduce concepts. Got it, everybody?
Got it. Yeah.
Okay.
Cool.
So we should just review whatever documents you send us over the course of the weekend.
Yes, Mohammed. I'm going to send it probably by my Sunday evening. That is my tomorrow evening. So that Monday I'll be giving you a walkthrough on that document only, which will be a replica for your real implementation of replication process.
Okay.
Got it, guys? As I said, you guys are claiming almost like 7 years to 8 years of experience in your CVs. Once your course is completed, and I don't want you guys to give a lame examples for your interview. I want you to give a live implementation only, assuming that that portrays that you are experienced person, and I want you to be trained in that way only. I can give you layman examples, guys, for which you don't need Mahesh. Trust me, even if you do Google it out or YouTube or whatever, you'll have a number of information on that. But how is that the data is replicated in the data center? How is that my client is given access through Hadoop cluster? And how is that my file system is supporting my client? How is it my YARN is supporting for the resource allocation here? How is it I'm going to access within a name node or a data node content and give the exact data within seconds of time, not in minutes? That is what is the main crucial point in Hadoop administration, for which you need to understand all of these processes. That's what we went through till now. From Monday onwards, we are going to do a different tasks here altogether. Okay?
Okay. Sounds good.
Cool, guys. Have a good weekend. Let's catch up on Monday.
All right.
See you then.
You too.
Okay. Thank you, Mahesh.
Bye. Bye.
Okay.
Bye.
Bye,
Guys.
Mahesh. Yeah.